The key formula we'll be using throughout this section will be the dot product formula. So given two vectors A and B, we can find the angle theta between the two vectors by applying this formula. A dot B equals to the magnitude of A, magnitude of B, and cosine theta. So this is the formula to find the angle between two vectors. How do we modify it to apply this formula to lines as well as planes? So we'll look at the first example between two lines. So the most important vector we have in a line is our direction vector. So given the equation of a line, you should be able to figure out the direction vector. So for two lines, we'll be using the two direction vectors, d1 and d2, and the angle between the two direction vectors happen to be the angle between these two lines. So using A and B as d1 and d2, we have the formula d1 dot d2 equals to mod d1 mod d2 cosine theta. The direct application of this formula may give us one of two angles. It could be this acute angle over here or the obtuse angle over here. So if you always want to stick with an acute angle, what we can do is add an extra modulus over here to make the dot product positive. This will ensure that we have an acute angle when we do the calculations. Next, we are also interested in the angle between two planes. That's the angle over here. So the most important vector we have in planes is the normal vector. So the normal vector is 90 degrees off of our planes. So if you rotate both planes by 90 degrees, you end up with both normal vectors. So this fact tells us that the angle between two normal vectors will be the same as the angle between the two planes. So we'll again use the same formula and apply our normal vectors to it. So n1 dot n2 equals to mod n1 mod n2 cosine theta. This will allow us to find the angle between the two planes. Our final case is the angle between a line and a plane. For this case, we have to be a bit careful because for a line, we'll be using the direction vector, while for a plane, we'll be using the normal vector. If we just apply the cosine formula directly, the angle we'll end up with is the angle between these two vectors. That's the angle on top over here. However, the angle between the line and the plane is the angle below. They're off by 90 degrees. So one way we can approach this question will be to stick with our cosine formula. After we find our angle, we take 90 degrees minus of it to get the actual angle between the line and the plane. However, there's a shortcut using of our trigo formula that cosine of 90 degrees minus theta is sine theta. So to get our answer in one step, we will use the same formula, but instead of cosine, we'll be using the sine function. So d dot n, the direction vector and the normal vector, is equals to mod d mod n sine of theta. So to summarize, for this section about angles, the basic idea is to use the dot product formula, a dot b equals mod a mod b cosine theta, and we use our direction vector for lines and normal vector for planes. The one case we have to be a bit careful about is the case between line and plane. So one way we can tackle that is to change our cosine function to a sine function.